Ma'am, Mr. Dhakshinamoorthy is sharing his screen. We don't have to put our banner.
Sir?
So our resource person, Mr. Dhakshinamoorthy sir, is sharing his screen.
Okay, okay, sir.
So we don't have to share our banner actually, right? So YouTube live streaming started.
Let me request you to get into the presentation. Ma'am, should I start recording? Ma'am, shall I start recording?
Oh. Your voice is very feeble. Can I start?
No, sir. You'll be introduced
Okay.
by the event team. After that, you can start. They have to introduce the topic, introduce the speaker, and all.
Yeah,
So-
we can start recording this Dr. Aguila. Shall we start recording? It's 6 by almost. Yes. PVS sir, shall we start now?
Please, please.
Yes.
You just wait for the recording to start. 1 second.
Yeah, she has recording. Okay.
Yeah, let it come on.
Yes. Good evening, everyone. I am very happy to welcome you all, especially Mr. Dhakshinamoorthy, the resource person. Thank you, sir, being with us this pleasant evening. And I also welcome the joint society members as well as CSA office bearers and all the participants in this G-Meet as well as in the live stream members who has already joined. I'm very thankful to you all for spending your weekend evening with us. And also I wish to introduce formal introduction of Mr. Dhakshinamoorthy. Mr. Dhakshinamoorthy has 29 years of experience in architecting emerging digital technologies. He has interested in Internet of Things, artificial intelligence, knowledge graph, and service architectures. He leads the technology advisory for IoT and DE units of TCS. As an enterprise architect, he has consulted and created architectures, IT secretary for customers across multiple domains, including manufacturing, banking, retail, life science, energy, and utilities. He has architected large-scale solutions for customer operating in global scale. He has extensive interest in graph technologies and how they can be used for knowledge graph. I think we all can experience and make use of his knowledge in graph technology, graph theory. Thank you once again, sir. Once again, I welcome you. You please, you can over to the resource person, Mr. Dhakshinamoorthy.
Yes, thank you, ma'am. I thank you and Subramaniam sir and CSI for giving me this opportunity. And I also thank the participants for joining. So I will try to cover knowledge graph from a perspective of what is knowledge graph. I'll try to introduce that. That by itself is a large topic, and there are multiple parts of it that have been standardized, and going through each of them can take multiple days, right? So we are condensing that and trying to cover the breadth of it. So I'm not getting deep into any of it, but I will try to give examples wherever appropriate and try to explain what is knowledge graph. Then we will touch upon how it is being used in the industries and what are the art of possible use cases that are happening with knowledge graph. Right? That is the plan. I will try to pause between when I move over from after I defining what is knowledge graph. At that time, I will give a pause. That will be around half an hour mark. Then remaining we will cover in second phase. So if there are questions, I will try to take at that time and then towards the end. So when we touch upon knowledge graph, there are multiple terminologies that one will hear when we are discussing this. And there are few questions also that pop in the mind. I know a graph. What is the difference between a knowledge graph? I know about mind map or concept map. How is it different from knowledge graph? Why you're talking about it so importantly? So these are some of the terms that we hear. And underlying technical terminologies per se, we hear about, ontology, semantics. So these two are the terms we hear pretty much when we talk about knowledge graph. And we also hear some of the acronyms, RDF, OWL, and Sparkle, which is pronounced as Sparkle, right? What does it mean? So those are all the underlying components that define what is a knowledge graph. Graph theory by nature is very theoretical subject. So let me try to start off with some examples and try to say what simply is a knowledge graph. So here in this first statement, I am denoting Dakshina is a friend of Subramaniam, and it is a bidirectional relation, right? So the arrow has two ends, indicating it is a bidirectional. The second statement, Dakshina is residing in Chennai. Now, both of the statements are little bit clear, crisp, defining a fact, bringing together two entities and describing the relation between them. Now, if we take the third statement, Dakshina likes apple, is a little bit ambiguous. Apple, am I liking a fruit, or am I liking the phone company or the product company? What is it? Now, can I give more meaning to it? We bring in descriptors, the types. So Dakshina is a person. Subramaniam is a person. His friend of is a type of relationship describing relation. Second one, again, it is showing the entities can be of different categories. City is a place. Chennai is of type city and place. So it is possible to relate between that also. Now we are giving a type definition. Now the third one becomes a little bit more clearer when I say, okay, it is Dakshina's preference and he likes apple, which is of type fruit. This makes it pretty clear about how, what the graph notations are bringing. That's all is knowledge graph by definition, right? This is a simple, we will get into the theory of what is knowledge graph. Now, knowledge graph as a term was first introduced in 1972 itself. But it gained popularity only in 2012 when Google, their VP of engineering, one Indian-born scientist, Amit Sangal, he announced through his blog and also official entry that Google is using knowledge graph. We will touch on this a little bit later. But that triggered a lot of interest in graph theory general and also how knowledge graph is being used. Almost immediately, all the tech majors, including Facebook, Amazon, Netflix, all of them started using it and they were putting out cases around it. That triggered the popularity, and also this started leveraging other initiatives that are happening in parallel. So let's now look into what the definition says. So first statement, that nodes representing entities and edges representing relations between the entities. This is a simple graph definition. What does knowledge graph make it? Knowledge graph conforms to a set of rules. It is using a specified as a heterogeneous directed edge labeled graph. Big words, right? Let's break those big words into smaller ones and see. Directed edges. A relation between the nodes is always directional. A graph need not have directional relationship, but knowledge graph says that it wants a directional relation. It can be unidirectional or bidirectional, as we saw in the example in the previous slide. Then we look at what is edge labeled graph. The edges, the relationships between the entities need to have a label describing the nature of the relation. It cannot be a nameless relation. Third statement, heterogeneous graph, which says that edges can be of different types, nodes can be of different types, and you can link between them. So that is what simply knowledge graphs, core graph elements are defined. So it is a heterogeneous, directed, and labeled edge graph. There is one more definition, which is a property graph, which kind of simplifies. So I have brought that also. Property graph or graphs where the nodes and the edges have additional information captured as attributes, which are called as property. So property graphs are there. We will see again some examples of this so that you are more clear. So here we take an example. I have tried to show a directed edge label graph. So two flight codes, LA380 and LA381, starting from and ending to. So here it is inverse, operated by the company LATAM, and it's a flight. It is starting, LA381 is starting from Arica and going to Santiago. And this one is the return flight from Santiago to Arica. Now there are additional information. Santiago is the capital city and Arica is a port city. And here lat and long of that cities are given. In all the relationships are named, all of them are having direction. There are multiple types of information, heterogeneous information is there. So this is a heterogeneous directed edge label graph. I can represent this in a property graph. So if there is a 1:1 relationship, typically those can be classified and brought into the property. So here in the Arica city, I have brought in the property of lat and long. I have also brought in the property saying that it is of type port city. Now, if there are more types associated with the city, say for example, Mumbai, you could call it as financial capital. Also, you could say it as a state capital. You could also classify it as a metro. So in such a scenario, you will retain relation types. But in this example, there is only one. So we brought it inside here. And again, LA380 is a flight. LA381 is a flight. Those are the properties. And the company type of LATAM is the additional property. Now, this graph is a very simplified representation of the same information. This is called property graph because this is having attaching properties for the nodes and if necessary for the labels also. Both of these are knowledge graphs. Both of them conform to the definition of knowledge graph. Now we will look at additional theory. What is ontology or semantics around this, right? So if we look at first, we will define terminologies. Terminologies are basically vocabulary that are used specific for that industry, right? So banking domain has particular terminologies. It will have account. Account has a different meaning. Whereas if you go to, let's say, retail, the account has a different meaning. So the terminology is defined for each of the industry. Now, one level higher is called taxonomy or a thesaurus, which could bring similarities, etc. together. So basically, it looks at abstraction of the terminologies. So can I abstract and give a industry level taxonomy that will be meaningful. So you could bring, let's say, automobile, cars, or type of automobiles. So you could bring an abstraction, and you can say automobile will have 4 doors, or maybe 2-door sports cars are also there. It will simply have doors, it will have wheels, it will have steering wheels. So that kind of relations you could bring, right? So you are abstracting, bringing some more meaning towards the terminology and bringing it at a domain level. That is taxonomy. Then third level is ontology. So what ontology makes it is these terms and terminologies gives a proper meaning. They make it as a concept. That concept has properties or attributes describing that concept. There are relations that describe the relation between the concepts. There are also, so these are all similar to the graph concepts that we talked earlier. Additionally, it can also bring constraints, which will say, okay, these are for the attributes, you can say some constraints. For the concepts, you could say constraints. For the relations, you could say constraints. For example, you could say an automobile type of concept is going to have only one steering wheel. So that is a constraint. It can have 4 or 2 wheels. That is another constraint. An automobile is designed to move from one place to another place. That is a function or a service. So basically, knowledge graph can be called the meta structure of a graph. So what does that meta means? Meta means description of the information. So you are basically having some information. You have so many types of cars, models of cars there. You are classifying it as a vehicle type. So now the vehicle, you can define single type. It will be applicable for all the cars. So this is basically a meta structure which describes how the graph is going to look like. So this is the ontology part of it. Now, second concept, we need to understand resource description framework. Now, RDF, as I said, like when knowledge graph as a concept started gaining traction, it started leveraging other things that were happening already. In year 2004, I think, W3C or World Wide Web Consortium, they started defining standards of how information between networked computers, internet connected computers, will be defined so that you can bring information together. So in the initial stages, though you could connect to a different computer, you cannot access the information easily. There were no index pages. There were no hierarchies defined. You cannot go through structures. You have to know what is there. So all of that they were trying to standardize. Now, knowledge graph was trying to borrow this and see how it can be integrated. So RDF was already started on class relationship property, which is very similar to our node, edge, and property. And RDF is always expressed as a triplet, a subject, an object, and a predicate. So what RDF defined is that it said that each of it is going to be uniquely identified by a URI, in this case IRI. IRI is a technical implementation of URI, basically a URL that you access to a website. So URI is the identifier, IRI is the implementation. So we don't need to go into the differences of it for our purpose. You can treat it as a URL kind of specification, which uniquely defines the location of the subject. So when you name an entity, that has to have a subject, that has to have a unique resolution indicator. So this is what W3C brought. Now RDF, again, the XML is very verbose, very big. So there were different formats of RDF that could be defined. RDF-A annotation, or JSON linked data format, or turtle format. So those kind of different formats came in. We will see one example with RDF XML type of thing. So example, again, we are looking at, okay, Tesla is an instance of a company. Now, Tesla was founded by Elon Musk. Tesla manufactures electric car, and Elon Musk was born in South Africa. Now, if I were to specify this with W3C standard, there are still some more complexities, but I just want to show the basic minimum complexity. So each of the node is now attached to a unique resolution address. So instance of is already defined relation. Tesla is an instance of company. So I'm using that URI, which is already standardized by W3 itself. So I'm using that instance type relationship definition that has its own specification. If I don't have a company definition, I will have to create a definition by myself, and I will have to publish it, so that the idea is the knowledge graph becomes interchangeable. So now others will know about this definition. Now they can access my information using this definition, right? So that is why we are making this also public. Now I am defining similarly other entities. Again, here, South Africa is a country. Country type is already defined. So country is already defined. So I have used W3's definition. All other things I'm showing as examples or created by our own ontology definition. Now, this is just one tip of iceberg of RDF. So each of these nodes will have RDF. So when we talk about attributes, relations, constraints, now each of that attribute is going to have a URI. Relation is going to have a URI. Constraint is going to have a URI. Functions is going to have a URI. Now imagine reading the document describing the RDF description of a particular ontology. It is going to be very verbose, very descriptive. That has been one of the drawbacks of ontologies. But before we come there, let's just touch on how it is useful. Why we do that? Now, similar to W3C coming and defining internet connection standards. See, remember, if we were in the 1990s when TCP/IP and HTTP became popular, connecting information, but you can't exchange. You can't see what is there. Your Google of today will not work. So how does that solve? it was by standard bodies like W3C coming and defining standards that really helped. So here also industry bodies are coming and defining what is my taxonomy, what are my concepts, what are the relations. So that makes it easy. So now let's say I have a vehicle ontology. If a new company comes or a new part supplier comes, they conform to this standard, they are able to exchange information seamlessly. So basically, interoperability and information exchange is what that was coming. But that was there already. So industry standard bodies were already trying to define the standards, interoperability was growing. What did knowledge graph bring in addition? They brought in terms of the functions and axioms that are defining specific for that industry, right? Functions. It will define what a vehicle type will do, what an entity defined for that particular domain will do. Axioms will define the constraints. It will define, okay, is it going to be 1:1, 1:multiple? These are all specific for that industry. Now, imagine that has been defined. Tesla comes in, it comes a better company than BMW. It focuses on what is the value creation I can do for the customer because I already have the knowledge. So existing incumbents face some challenge, but they can information exchange and the values they get because of that drives this initiative to more and more adoption. Now the last three part, let me just touch on it and then we will move to the examples. Sakthivel. So now you have all defined your standards. Can I access it in a standard way? So there needs to be a query language. So they brought in a semantic RDF query language similar to SQL, but able to understand and interpret RDF concepts. So again, this will be driven by URI specifications. The query entities will resolve that and basically come with this. So it's slightly verbose and complicated if you're not using it for internet purposes. So if a Google-like company, it will benefit very much. Will it benefit a banking company or an automotive? Maybe not. So there are people who come with their own concepts. So GraphDB providers started coming with property graphs. So the example that we saw earlier, they gave a very simplified mechanism and you go with their own language that comes. So there are pros and cons to both these approaches. That is not the focus of today's discussion. We will just try to understand this. So this is the various concepts of knowledge graph. So if you see graph theory and graph databases started as schemaless. You can put any relation, any entity, any relation between that. Then it becomes very difficult to manage. Now knowledge graph gives a schema to that graph that converts this data to a more meaningful purpose. That is what we saw in the very first example, how graph knowledge graph concepts provide meaning to that data, right? With this, I will just pause. If there is any questions, or shall I proceed, continue further?
Sir, you can proceed actually, because at the end
Sure.
of the session, questions will be pooled and one of us will be asking the questions.
Okay, sure. Yeah. So now let's look at how it is applied. So yes, Google and other internet giants were showing how knowledge graph will change how their results are coming up, right? So when prior to knowledge graph introduction in Google search, the search will just list down whichever web pages are having the terminologies that you want. Say, for example, here I'm searching on Winterthur, Zurich, a location in Zurich city. In before knowledge graph, you will get list of web pages that are having this word. It will not tell, okay, what is the importance of that. But if you look at, let's say, Wikipedia page, you have lot of meaning about the data. So Google thought, can I bring that kind of meaning to this? So they brought in, okay, some of the types. So they said, okay, if I identify this as a city, I need to bring, okay, it is a tourist city. I want to bring top sightseeing places. I want to bring about weather. Or here they have actually narrowed down that it is a hilly place and they are trying to show elevations. So there are several algorithms working on the node types. Say, for example, which node type to prioritize. So you might have heard about the page search algorithm and all. All of them are based on graph theories. And in this case, specifically, they are bringing the knowledge graph concepts, right? So they are making the type, and based on the type, they are showing the relevant information that is required for the user. Second purpose that we use is reasoning. So we have, with graphs and knowledge graphs particular, we can accelerate reasoning. So for example, in the first example we were saying Dakshina likes apple. Instead, if I say person Dakshina likes fruit apple, and now I'm able to use these concepts, inductive, deductive, or abductive. So in inductive, we basically, based on certain facts which is stated, you try to create a theory. Now, facts, for example, we got an entity which has wheels, doors, seats, engine. We can infer it is probably a car, right? So that induction can be had. Now, deduction is you have theory, you are able to derive facts out of it. All cars are vehicles. Dakshina has a car. These two are facts. You are able to deduct now Dakshina's car is a vehicle. So this is deductive reasoning. Third, we look at objective. You have certain facts, you have certain uncertain facts. Now you go into a possible conclusion, right? So you get into possibilities of reason. Let's look at one more example. So the left-hand side, there are facts. Based on the facts, now cat has 4 legs is not stated in the fact. With using knowledge graph, you can deduce inductive principles. You can deduce that. Now graphs also is a very easy mechanism for introducing new facts. So if you introduce a new fact that birds can fly as true, and penguin is a bird, you can't simply state that penguin can fly, because already there is a penguin can fly as a false. So when you do inductive reasoning, you have to validate once again that you are not contradicting any of the facts. This is a basic principle of inductive. I have shown a very simple example. So you could say that inductive reasoning is validated. Now imagine a very large graph. Imagine a LinkedIn graph. So many millions of people are linked. If you have to do inductive reasoning, how complex it can become. Now, instead, can I do inductive reasoning on the types? Types are small graphs, right? You will have so many number of people, but they are either Asian, they are either Indian, depending upon your level of type creation. The types are small graphs. So inductive reasoning now can be done on a smaller type reasoning graph, knowledge graph, and applied further on the instances, and the results can be shown. So you can see how it is simplified. Now, for us, industrial applications, we do failure analysis. Let's again take a vehicle example, right? So you are having a failure in the car. What do? You call the mechanic, or if you're a little bit inclined, you call, or you can look at the manual. You look at what are the possible causes. Okay, it lists down steps, or have you done these kind of steps? So there are checklists and activities that you do. Instead, if I had captured those as facts, as graph, I could deduce that through those three categories of reasoning, and I can tell this is the probable cause of failure. This is very much possible. This is one of the use cases, that are prime use cases that knowledge graph happens. Now, we look at the high volume data example that I cited. So LinkedIn data is a very popular example of graphs. Similarly, Facebook. There are a lot of social networks are all graphs. So how do you use that? How do you leverage it? So the concepts we use are graph embeddings, which is basically assigning a score based on different parameters. So basically you can say, okay, LinkedIn demography based. So it is South Asian, Indian, Tamil Nadu. So like that, they can define whatever types that the LinkedIn marketing customers are required. So they are selling the data somehow in the background, right? So they will create the types of dimensions of knowledge that they want. Based on that, the graph embeddings are created. Basically, it creates a scores based on various parameters. So you use algorithms like random walk or graph sage, those type of algorithms. So this summarization, by rather than doing on a structured data, if you do on a graph data, it becomes much more easy and much more better. Now, vector is a form of graph. It's a unilinear graph. So the vector database and the vector embeddings have gained popularity after LLM. So after ChatGPT has been launched, LLM embeddings, vector embeddings are very popular. The graph embeddings are multidimensional, vector embeddings are unidimensional, right? Second one is about prediction. Now we talked about deduction reasoning, can I do predictions? So I have a large LinkedIn network. So if you log into LinkedIn, it is recommending, hey, do you want to connect with so and so person? So basically, it is doing a link recommendation. Similarly, you can also do node recommendations. So all of this is possible using the neural network concepts on knowledge graphs. Now, third, little bit complex is similarity. So similarity is basically, I look at, okay, the graph. I know I have done so many things in the past, and that graph and this graph has some patternal similarity. Now, all the things together can potentially cause a problem. Think about it. Now, stock market price. How does the share price move? Is it simply because of one announcement from the corporate? Is it that? What else is happening? Something happening in the news? Something happening in a war between Ukraine and Russia? A pandemic happening? So all of these are patterns. You could use all of this pattern, do a better prediction of the price movement than by just looking at the corporate balance sheet alone. Yes, of course, the corporate balance sheet has a lot of weightage, but all this interconnected events also have an impact on the price. So can we identify such similarity? Now, when I want to extrapolate that similarity, when I do it on a simple graph, it becomes complex. So we use the knowledge graph plus the neural network to make it simpler. Now let's look at an example. But this example is not using similarity. It is still using the reasoning type of things. On the left-hand side, there are multiple facts that are given, basically given from how the card has been used. There are multiple facts that are coming. Now, is there a fraudulent transaction? That is the question. There are several rules-based reasoning or the concepts inference, the three types of reasonings that we talked about. You could use those techniques to identify that. But when this data becomes high volume, imagine a player like Citibank, which is a global player, having so much of card transactions happening. Typically, bank transactions can happen in a particular geo, but the card transactions can happen across the geo. So it becomes more complex. The volume, the diversity, all that. So you could use the similarity and embedding techniques to do that, identifying the similar patterns. Then you know the fraudulent transaction has taken place. You can identify if it is happening now. And this is being used in the banking industry very much to identify. And this has been one of the strong use cases for the banking sector. Then we have seen the ChatGPT launch that has brought in a lot of interest, and it is a era-defining AI activity. But then it is also having implications in terms of how knowledge graph is being used, can be used with it. So large language models, ChatGPT is a large language model. So basically, it has been trained on the world level global level, language data, all the public information, it has been trained. So it is a large language model. Now it is answering all kinds of queries. But when I take it to an enterprise, will it answer a query specific to ICICI Bank? There are differences. So it is not efficiently answering when we ask queries with respect to a particular enterprise. So how do we enrich it? So can we do a knowledge graph on top of LLM? Can we interact? I will show this as an example in the next slide. The other ones, we will talk on it. So LLMs are talking about, so initially when it started answering a lot of queries, they were trying to play with it in terms of reason. It was also able to do one level reasoning or two levels of reasoning, but when they go into multi-level reasoning, chat GPTs are not performing well. So now the interest is, can I combine knowledge graph with its multi-level reasoning to fit on top of or feed, augment what chat GPTs are doing. Third one, okay, can I enrich information that is retrieved from chat GPT with information from knowledge graph? In the first one, knowledge graph is the front end. In the third one, chat GPT is the front end. So you do a query interface first, is the third one. Fourth one, okay, we have knowledge graph. Can I now create it with LLM? So LLM can do so many things. Now, can I use it to create a knowledge graph itself? There are people who are working on that also. There are use cases that are happening on that. Because the documents that are within enterprises that are still not systemized, is not brought into the system, is still high volume. Now, let's look at the first one a little bit deeper. So from the user interface, sorry, I hope the size is okay and visible. Okay, so from the user interface, first we ask, okay, what is the instance? So it is a query about a LinkedIn person or something like that. Now using knowledge graph schema, can I identify the type? Then from the type, can I generate a query for the graph? I get additional information. I pass that to, again, chat GPT. I generate a more reasonable query. With all this, I give a response back. So this is a place where knowledge graph is in the front. There are other places, the third model that we talked about, you directly query the LLM. The chat GPT is the first place where you query. Chat GPT goes into it. So your query is something very specific to your enterprise. It doesn't find it. It has provisions to hit on the enterprise data. So it comes to hit your API, which goes into the knowledge graph, retrieves it, and gives it back. So this is largely how LLMs are working on knowledge graph integration together. So some of you were asking, okay, what areas should I focus? So this is if you understand the fundamentals of knowledge graph. This is a very interesting area that is happening, LLMs and knowledge graph. Or if you are looking at neural networks and how knowledge graph is being used is also an area that is being used. But for all of that, you need to understand the fundamentals. What is a graph? What is taxonomy? What is ontology? How do I understand the types? And all of that linked together is what is your knowledge graph that is getting applied. So with this, I'll come to an end. If there are questions, I can take.
Dr. Akila, please.
Yes, ma'am. Can you hear me, ma'am?
Yes.
Yes.
Thank you, sir. Thank you for the session. We have some few questions which was asked during the registration. First question, how companies are using knowledge graph?
Yes, I tried to address that with specific examples, right? So I did give examples about how failure and root cause analysis is happening. This is a credit card example is banking industry being used. So these are all specific examples for each domain. So we can take these kind of examples, but the fundamental concepts that are being applied are induction reasoning, these type of prediction of node prediction, link prediction, similarity pattern identification. So these are the graph concepts that are getting applied for industrial problems. I hope that answers.
Thank you, sir. Next question. What are the comparative differences between knowledge graph and concept map?
Ma'am, your voice has gone feeble.
What is the comparative difference between knowledge graphs and concept mapping?
Okay, I tried to answer it in the first set of definitions. So if we give a knowledge graph has more meaning. So if you say a concept map or it is going to have a map of what you are interested in and what are the subjects and what is the relation that you have. But a knowledge graph goes beyond that. It describes the attributes. It tells what are the functions, what are the constraints, what are the axioms around it. So that is how knowledge graph is much more robust than a mind map. Mind map is for a different purpose. It is simplified to capture your ideas. Concept map is to capture your ideas. But this gives more concrete meaning so that when I come for an industrial usage, I'm able to use all these things. I hope it answers.
Thank you, sir. Question from the chat box. Could you please explain again the objective reasoning example?
Objective reason. Okay. So basically here, we have certain concepts and knowledge, general knowledge is there as a knowledge. We have some uncertain facts. Can I use that to make a prediction? So it is not, so it depending upon how well you are confident about it, the recommendation or the conclusion is the confidence nature is on that. Now the example here is the first two statements are facts. My car is not in the garage. My family and myself are in my home. So why is the car not in my home? I could have lent it to my friend. I could have given it for service, or it is possibly stolen. Right? So the third statement is uncertain, but I come to a conclusion based on certain patterns that I have identified. That is objective reason. In inductive reasoning, you are reasonably confident. Okay, so it is having certain facts, and you are also having certain facts which guides you to tell with reasonable confidence, yes, this is a car. That is the difference between inductive and abductive reason.
Thank you, sir. Thank you so much. Next question. Can we build a knowledge graph and store it in a database like Neo4j or Ocean DB?
Voice not audible, Amma. Akila, voice not audible.
Is it audible now?
No. Keep
Are
the
you-
mic closer.
Are you taking the question from the chat box or previously given one? I will read it.
From chat box, ma'am.
Chat box question. Okay, I will try to read it. One second.
Okay, I will suggest a beginner's tutorial. Okay, you are talking about tools and libraries. Okay, I have this book is an actual good resource to learn. And again, RDF and Sparkwell is also, this is also a good place to start. I will share some resources on the tutorial. From the libraries, okay, again, these are all standard libraries that are available. So if you go to RDF specification will give a standard library. Sparkwell will have its own standard library. So all of the standards, so these three standards have their own specific libraries available. I will also share on top of it the Protege type of frameworks which help in this. So for example, Protege is by Stanford on knowledge graph. So if you Google up on that, you will get a editor. Yes, there are also Python libraries also there for knowledge graph. Let me just Google up on that. I will share with you something on that. Probably post the session, I can share it. With respect to tutorials, and okay, I have one good YouTube channel, which kind of helps you to go through a lot. This YouTube channel is good. You could use this as a tutorial. So for Soumya, I will share the Python libraries little later. But other open source libraries, you should be able to get it standard. Okay. I think I have answered the questions in the chat box.
Sir, there is
Yeah, I glad that registration questions have you done? Oh, okay, I will read it out. Okay, how companies are using knowledge graph?
Yes, I already answered that.
Okay,
It was asked.
okay, that is also all the questions over, Akhila.
that box.
Chat box questions are over.
One more question is there. Ma'am?
Which
Yeah, can we not build the knowledge graph and store in database like Neo4j or OceanDB for a large data set?
yes, Neo4j by itself says it has knowledge graph, and our team, we are using extensively Neo4j for knowledge graph. Now, when it becomes difficult, so if you are in few hundred thousands or few millions, you're still good. But
Yeah,
when you are
OceanDB
going,
is very, very large, sir.
um,
So multidimensional.
so if you see Neo4j, they also talk about the statistics per se. They also talk about the large volumes that they handle. Why, when it becomes difficult? So yes, when you try to visualize all these aspects. Now, when you also try to summarize or see inferences that can happen. So we talked about an example where an inductive action needs to be verified again with all the facts. So what happens is you create an inductive inference. You understand something. You now understood that penguin is a bird, so it can fly. But that has to be validated again against the facts, which is completely in that. Now, this inductive reasoning becomes difficult if you are not having either embeddings or a type-based validation. So in Neo4j, I don't know OceanDB well, but in Neo4j, it is a property graph. So it is a form of a knowledge graph. But where Neo4j is weak is it doesn't have the schema. But there are add-ons in Neo4j which allows importing schema, and that could be understood. So in our industrial digital twins that we have built, we are using schemas on top of Neo4j so that it is becoming easier to instantiate other types. See, one problem that happens for us, I will tell on the Neo4j itself. When we did industrial digital twins, it's basically, let me take a simpler example. A big office building has big chillers, okay? It is called HVAC, okay? High capacity air conditioners, something stands for the V. The HVACs have multiple configurations. So you may buy from, let's say, Voltas itself, the configurations that you set up in, let's say, Phoenix Small will be different that you set in PVR. And even within the Phoenix Small, you may have different parts set up differently. So it will have what is the inlet airflow, how I should circulate, what decarbonization I should have, how much fresh air I should let in. All these configurational settings are there. It will be different. Now, when we do analytics, okay, I do remote operation. Let's say I am a building operator who remotely monitors that chillers. And I want to ensure it is working. Now, these are different settings, different parameters, varying from each setup. I have to make inferences. If these settings change, my oxygen flow is disturbed, my fresh air flow is disturbed. How do I do that? For me, if I do it on a typed graph, it becomes much more easy. Otherwise, you could do, if the volume is less, so you could always do that on a simple graph. You don't require a typed knowledge graph. I hope that answers you, Sharon.
Yeah, very well, sir. I think.
Okay.
Mythili, ma'am?
Now I
Yes, I request Dr. Gomati to deliver a formal vote of thanks.
Yeah, thank you, ma'am. Good evening, all. On behalf of ACM Chennai, IEEE Computer Science Madras, and CSI Chennai chapters, myself, Dr. Gomati, Vice Chair, CSI Chennai chapter, take this opportunity to propose a vote of thanks. At the outset, I thank the chapters jointly organizing this webinar on knowledge graph and industrial applications to enlighten us today how knowledge graphs are applied across various industries to minimize the cost, maximize the productivity individually or collaboratively. I heartily thank our chief speaker, Mr. R. Dhakshinamoorthy, Managing Partner, Technology Advisory, IoT DE, TCS, for spending his valuable time with us to demonstrate how knowledge graph represents the interdomain operations digitally, adhering to data standards for information exchange across domains. Knowledge graph along with the neural networks can be utilized in prediction too. He also indicated that KG, that is a knowledge graph with the multi-level reasoning and LLM, which are embedded in ChatGPT. And also I thank the speaker for clarifying all the queries given by the participant diligently. My warm thanks goes to the participants who showed their enthusiasm throughout the webinar and actively participated in the QA section. I hope this session will encourage the researchers to innovate new models, prototypes, or archetypes. I'm thankful to Mr. H.R. Mohan, Chair Events, IEEE CS Chennai chapter, who diligently work to present such cutting-edge expertise to the community. I thank all the office bearers of CSI Chennai, ACM Chennai, IEEE CS Madras chapters who supported this event. With these warm words, we move to the end of today's event. Thank you all. Good night.
Thank you, Gomati. Thank you, sir.
Thank you, all of you. Thank you, CSI Chennai.
Thank you, sir.
Thank you.
Really
Thank you, Mr.
excellent.
Dhakshinamoorthy, sir. Thank you.
Thank you.
It's very informative, but I think this is cannot be completed in one single,
Never.
Yeah.
Within 1
We
hour.
will
it is
try to
very
arrange something more, sir. Thank you.
Sure. Thank you.
So
Thanks.
we'll
good.
meet
Try
more
to
often
have
and
one day workshop, sir. Kind of a seminar. If you could get time, that's all.
Yeah, that is more important.
Offline. It should be offline.
Sure. Yes. Yeah. Thank you.
For that, sir.
Thank you. Thank you, sir. Good night, sir.
Thank you, sir.
Good night. Thank you.
Recording stop.